IT. So we will begin from there itself, our session. So now the thing here is BI is any BI tool, let it be Power BI, Tableau, ClickView, all these are your analytics tool. That is, they help you visualize data at a very high speed and easy way so that the business can look at those dashboards and indicators and make business decisions instead of running SQL queries and wasting half a day every day in determining what is the one that is factors that are impacting their business. So generally, the people who do these kind of developments are called Power BI, BI developers in general. But and as you grow up, more of an analyst you become, and you become a data analyst kind of thing. So there is a thin line between what a BI developer is and analyst is. In a very vague term, if I will throw it at you, simply understand that when you join any firm as a fresher or something, then they generally give you the requirement. Okay, this is the charts that we want. These are the fields that from which you can plot the charts, and you do it accordingly. So that's what you begin with your career with as a BI developer. But as you get on experience, even if the person comes up, this is the data set, and we think that this is the chart, you will raise up, no, this, I don't think this is the most right chart for you. You should go with something other chart that is more accurate for the data set that you are pointing to. Or even you will start suggesting them that, okay, this is one of the factors that I think is impacting our business. So let's make a KPI on this and show in our dashboards kind of thing. And that will impact our business in a good way. So that's how you transition between these two roles. Everybody starts their role in BI sector, the engineers generally as BI developers. And there's a thin line. As you grow up, you understand the data and you become more of an analyst kind of thing along with your BI development. So that being stated, obviously, few people would have more interest in being an analyst. Few will be more interested in being more of a BI developer. That's your personal choice. But for both the roles, BI tools are very important. That being said, let's refer to the following chart. I hope everybody has the chart visible. It's from Microsoft site itself. So what this chart does is show you the magic quadrant. It is issued by Gartner every year. Gartner is one of the most prestigious institute that gives you the list of all the tools for different sectors, maybe BI or AI and those kind of things. And so every year they leave a list of stuffs in a quadrant. You can see the challengers, leaders, visionaries, and niche players. So among these, who are according to these quadrants, industry is very influenced by this particular charts because they know that who are leading right now for this particular year. So Microsoft, with the help of Power BI, has raised the game very much in, I will say, last 5 years, because Power BI is not even older than 5 years, whereas things like Tableau or ClickView are almost close to 20 years or more. So last year, Tableau was the leader and ClickView was second raising. But this year, Microsoft has beaten both the tool to be the leader, followed closely by Tableau. So these are the most popular tools right now in BI industry. And ClickView is lagging behind, but it has been, I will say, one of the longest tool in the leaders board in the industry. So then it's also a very popular tool that we use as a corporate industry. That being said, we are going to talk about BI, Microsoft or BI this time. So what is Microsoft Power BI and what are the environments in which we will create it? So let's, for those of you who don't have installed Microsoft Power BI, I'll recommend, if you do get time in parallel, download it and do install it, because that will come in very handy as we will work on. Because we will have a more of a practical workshop than a theoretical one. Because theoreticals I always find boring. So that's how we will do it. If you have a question or a doubt, feel free to ping me. I will try to answer as much as possible. So yeah, before we begin, just give me for everyone who has a Power BI installed at their end, do open it at your end so I can let you know what we are going to do. I will give 2 minutes time to everyone. Meanwhile, I can let you share the data sets with you. Just give me 2 minutes. Meanwhile, please open your Power BI, everyone. So now I have shared with you guys a link in the group chat. For those of you on YouTube watching it on YouTube, I think Gutesh can share it with you guys. The link has all the data sources that we will be using today. Yeah, obviously you can use. Somebody asked that you can use. Thanks, Gutesh. So now that somebody asked me if we can use Power BI in MacBook. Obviously you can. The only difference is that the Power BI in MacBook will have a different version than the one on Windows because they are different operating system. So you have to download the right version of Power BI for your tool, but it is supported on either of the platforms. So now I hope everybody has opened Power BI and the link has been shared. So you should have downloaded it. If not, please do it because as we will proceed, it will come very handy if you want to practice along beside me. So when you open Power BI, the homepage looks like this. You will have, obviously there is something called sign on that helps you to create an connection with the server. If you are publishing your dashboard or something, you need to sign on with the Power BI or even importing the visual from marketplace. As we'll work on it, it will be more clear. In short, in a very naive terms, we can say that Power BI has a desktop tool where we create the dashboards and we publish it onto web server. Now, web server for any BI tool, not limited to Power BI, even Tableau does that. They have generally two versions. One is on premises, other is off premises, that is on the cloud. So the on premises version means that the server will be installed on your local system, in-house system, like you have an organization. So you will have your own servers. And that Power BI report server will be installed there. And the people in your infrastructure team will be keep maintaining that. Obviously, there would be sometimes issues which you will not be able to solve your infra guys. So they will raise a ticket to Microsoft and they will assist you to solve the problem, but they don't have direct access to your BI tools or BI server. You have to give them logs and assist to work with them to solve the issues. The server maintenance and everything belongs to your hand. The loss is that average maintainability is on your hand, so that's an extra cost. On the other hand, the benefit is that your data is more secure. Banks and critical data, they don't want it to be published on cloud, many organizations. So they use an on-premises server. So Power BI report server does that for you. On the other hand, Power BI cloud, which can be accessed through the URL app.powerbi.com. It's a Power BI cloud. So if you have a access, if you are publishing your dashboard there or your reports there in a better term, I would say. So if you're publishing your reports there, then what will happen that if the server goes down or things like that happen, then it's not your responsibility to take care of that. It's the Microsoft guys. They have the maintainability. So anything like the gateways goes down, the server goes down, they are the ones, they have already clusters and things like that. So that even if one of the servers goes down, they will have a backup server which will support your organization and they will in meanwhile fix it without your knowledge itself. But even if everything goes wrong and the servers gets down, then also you don't have to raise ticket or talk to anyone. They will issue a comms to global audience that this something is going wrong and we'll try to fix it at the earliest. So in an hour or two at max, the worst case scenario, it gets fixed. So that's the benefit with the cloud, that you don't have to care about the maintainability or things on them. But on the other hand, your data is on cloud. So the security of your data is with Microsoft rather than your own organization. So if there is a breach there, your data will be open to public. So that's the two on-premises and on-premises platform that exist. And I think everybody would have been clear with the difference between the two. That being said, now if you have to create an account on Power BI to access service, if you have a business ID, you can use that business ID. You can use that business ID to create your account for a free trial of Power BI Pro license for 2 months. So if you have a business ID that you used and you have already not used Power BI, you can use it for a 2 months of license to try it and publish it on cloud, not on premises. On premises, you have to pay for it. For cloud, you have 2 months of free subscription. So somebody asked me that is cloud better than on premises? It totally depends, as I was telling, it totally depends on what your priorities is. If your data is very critical and if it loses, it can lose or make you a loss of $billions of dollars. No, it's not better than on premises. On premises is still the best thing for you. But if you have a data which is not that critical, which can't lead to monetary loss, and then a cloud will be a better thing for you because you don't have to put extra money on maintaining a single team that will only be responsible for maintaining the infrastructure and maintainability kind of thing. So I guess that helps you with the decision that you have to make between a cloud or an on-premises server. That being said, let's get to the practical things that we are doing. So now, as you can see, this is a home screen that you will see into the new Power BI dashboard workbook if you open it. So now you can see there are visualizations as you open on the home screen, visualization, fields that are empty, filters that are again empty. These are empty because we haven't imported any data yet into our BI tool. So this is the first section, which is the report page. Next we go down, there is a data page. Here everything that the data that we will load will be visible. The tables will be visible in a tabular form. And the third is the model page. Now this is the page where we set relationship in Power BI. So what is the relationship page? We will discuss this in way more detail in next session. But in a very naive term, I will say that instead of taking 5 tables and joining them together and creating a very huge data set, what we do is we create relationship between the table. That is, there is no practical joins, but we have a cause clause that if I pull a column from one table and another column from two tables, they will be joined on the basis of relationship that I have created at that instance, but not the data in the what we'll say extract file will be saved as already in the a single table. So that's the benefit of relationship. It's a very big to you, I understand. But as we will proceed on this, it will make very clear contrast to you from what the normal joins or tables is. So we'll catch on that later. But let's have a brief kind of intro on that. So that's why we did this. So now you know the three platforms. So what we do here is any calculations that we will do in Power BI in this platform will be called DAX calculation. These all calculation evolved from Excel, Power Pivot, I think they were introduced in, and they moved forward and became the basis on which Power BI does the calculation and everything. So the way you calculate in a Power BI, the recommended standard is anything that you can do in SQL, the calculations or the folder rename, anything that you want to do. So as many of your calculations you can do in SQL Server or your data source, maybe JSON file or in Oracle Server or a cloud. Or wherever you are storing data, do as much of them at your data source, because that will reduce the load on your Power BI server to do the calculations. Then comes the M query. M query is more of a like a ETL part where you do all the transformations before you load your data into Power BI. It's kind of the ETL part of Power BI, you would say. So then do the most of your calculations that's are possible in M query. Everything is not possible in M query, otherwise just wouldn't exist. So do as much of your calculations in M query as possible, because they will again, as we will learn, there is something called data folding that's come into picture into M query. So they will again not do all the calculations at your Power BI server end, but partially at the data source end also. So that reduces the workload on Power BI services. Then at the end, only those calculations which can be entertained at M query or a data source, only do those calculations. There will be a lot of calculations that these two level can't entertain. That's why BI tools does exist. Otherwise, BI tool won't be into picture. Only we will do those calculations into DAX. That is the Power BI interface. So that's how the hierarchy of calculations is in a good development model. So that being said, a lot of theoretical part we have talked about. So let's move to the practical. So we'll go to get data. We have an Excel data source. Power BI sets. Power BI sets are something that is already published on Power BI server. You connect to those servers and get it from there. Power BI data flows, again, something that we have you publish a data flow on server and pull it from there. So we won't be using that. There is SQL server. Just like then analytics server. Analytics server is something where data is saved as a cloud. That is a three-dimensional data. So cubes, you will say in a naive term, if you are from IT background, you'd have heard of cubes. So all those data comes under analytics services. So you connect to analytics services to get them. Then text or CSV file. Web. Here, if you have a tabular form like we will say the list of IPL winners in a single page, web page published, you can directly put that URL, and Power BI will give you option to connect to one of the tables that way. So identify which is the correct table there, which has the list of the players and IPL winners or those kind of things, and directly import. So that's what web connection means. Blank query is something when you want to write the data source itself with in the Power BI instead of importing it from somewhere. They come in very handy when you have to put some arbitrary values that you will use in other calculations. When we'll do a practical example, like a small project kind of thing, we will be using a blank query. So it will come handy there. And there's a way more to go. Power BI has can connect to LinkedIn, Facebook kind of things. So there is a way you can see Power Platforms, Azure, clouds, snowflakes, things that we haven't heard of can be connected there. But at the bottom line, we will work with the basics, because at the end of the day, it's generally a SQL server, an Excel file or JSON file that we do connected. And doesn't matter where we connect, most of the calculations and transformation in Power BI remains the same. So I will go with Excel because the data sources that I have provided you are in Excel. So somebody is asking if I can run a Python script in Power BI. Yeah, you can run a Python script in Power BI to do calculations. Calculations in a way that what we can say is that there are some algorithms like forecasting and things like that that Power BI forecasting doesn't give you the desired output. So for those kind of things, you can run the calculation in Python or R. You can see there is, as my cursor is pointing, there is somewhere thing called PY and R. When you use these visuals, what they do is you can write the calculations and they will run it in Python and R and give you the output in Power BI. Obviously, for this, your tool has to the Python or Power BI installed at your end. So yeah, you need a Power BI along with Power BI. You need Python or a R script installed at your development machine if you are using them. Yeah, not exactly as SQL Server, because SQL Server will import the data itself at the very first step. But in Power BI, our Python, we do the calculations on that data in Python, like algorithm. So now we have data sets. I hope you all have downloaded the data sources. So we'll move there. So let's take something. Let's begin with employee. And employee pay. So I will select these two things, one after another. Let's first pull employee table. So now you will see the employee table has 3 sheets in them. If you open it at your end, let me open the Excel itself, so it is more evident to everyone that what we are doing. So you can see the Excel sheet. I hope it is visible to all of you. So there are 3 tabs in that: person 1, person 2, and employee details. So person 1 and person 2, you will see that they have the same structure and same column names and the same almost similar details. Not the same details, but similar details. An employee table has the details of the employees. As an employee, when did they join, how much sick leave and vacation they have. And person details, they have the details as a person. That is, what's that employee name, what's his email address, where he is from, things like that. So now that we have seen that, we'll use that into our calculation. So coming back, we have 3 tables: employee detail, person. When you click on it, you can see a preview of that table. If I load them directly, they will simply load it into my Power BI without any transformations, and we will be good to go. But we are not going to do that. We need to do transformations. So we'll click on transform data. So now let me disable a few things which are by default disabled. I only enabled it for myself. So this is how your data will look initially when you click on your transform data. This is what we call a Power Query window. It's different from your Power BI editor. Your man window is different, and this is something called Power Query window, which we use for doing all the calculations. Let me take you to the Power Query windows. Uh, I hope everybody has the Power Query window visible now. So Power Query windows shows you the list tables as a list. On the left, you can see employee table, person table, and person detail, two tables. So the first thing that we see is on our data is ignore the calculations there that Power BI does automatically for you. If the column names are correct, if you click on those numbers, it will show you the data types that are exist there. So it has decimal numbers, fixed decimal numbers, then whole numbers, percentage, date, time, time zone, duration, text, true, false, that is Boolean, and binary. So pretty much what they are, it is quite evident with the symbols that they recognize. So Power BI is smart enough to use the correct data types against your original data. But if it doesn't, you can directly click on it and change it. So let's go, right? Let's see if everything is correct. Second is text, third is number, title is text, first name is text, second name is text, suffix is text, email promotion number, text, number. So everything looks good here. Modified date. Now there's the problem. So did everything got modified on 12th AM every day? Not exactly. What happened was that the data stored was in the form of dates in our Excel file. That is, if you see the Excel, it would have been stored like 30 July 13, 10th November 13, and there was no time. But since Power BI tried to add a number, it has date time by default, recognize it. So it added the very first time of the start of the day, that is 12 a.m. to it. So that's why it is showing as 12 a.m. So we don't know that 12 a.m. is not right. So what we'll do is right click on it and change it to date. So it is asking if I want to change it to date as a next step or replace current. I will click as replace current. If I would have added it as a different step after changed type, there would be another step here called change type. This takes the control and shows what the changes are being made. So here we simply change it from date time to date type. Similar thing would have happened with person detail 1. See? So we will go here and change it to date type. So now we have two tables with same data structure and similar data, that half the persons are available in table 1 and half of the persons are available in table 2. So for this to be in a practical use, you'd want them to be in a single table. We can do this in SQL Server and tools like that using union, a union statement. So for a union statement to work, logically there are two restrictions. The column name should be same, arranged in a similar way, and the data type should be compatible. Whereas Power BI has something similar kind of restriction. The Power BI allows you to join even the column names are different, then it will only create you null values for the columns that are not matching, and that doesn't make sense. So if you are doing union, you should have the columns with the same name and preferably the same data type for a logical matching. So now we will go to home. There is something called append queries. That's what Power BI called what we call union statement in SQL Server. So I will select both the table, employee 1 and employee 2. So there is two options here. Append queries as new. What append queries does is instead of creating a new table, it will append the data of table 2, person detail 2 in person detail 1. But if I select append queries as new, what it will do is it will create a new table itself altogether where it will append the data of both tables. So let's go to append new. So it is asking you if you have two tables or three or more tables. If you have three or more tables, you can like drag and drop there. If you have two tables, you can select the second table. So first table is person level 1 for me, and second table is person detail 2. Now obviously the I have selected, as you would remember, in a create a new table with append. Not so it will not add it to any of the existing tables, but create a new one. And there we have an appended table. With the same, but how will I know that the number of rows is exactly the ones they have appended or not? For that, let's come to here something called view. This is something called column quality. With that, there's something called column profile, and there's something called column distribution. For now, we will use column profile. So in column profile, we can see and see column profiling is based on top 1,000 rows. If we want to see, column profile is very powerful thing. We don't use it for this such a simple thing, but I just wanted to show the count, so I'm using it. So I'm using column profile on entire data set. This is not recommended when you have a very large data sets, because if you start profiling on a data set with billions of data, it will just slow down the whole purpose of column profiling. So only do it on the entire data set when your data set is small. So now you can see there are like 19,000 records here. Coming to a second table, have 177 records here. And the appended table, let's make it on entire data set again. And you can see both the numbers gets added up to create the combination of a data set here, total count. So that's not exact the use of column profiling, but you can use the column stats as one of these three also. So now we have a table with both the values. Let me disable the column profiling for now. And let's move to the table. So we have something called business entity key and something called department key, if I'm saying. Okay, so that we don't have. So we have a business entity key here. That's all we have as a key. Nothing else but a key we have. So before we proceed, let's rename the table to make it more logical sense. Person details. Union. Okay. So now if you go to the employee detail table, employee detail contains detail about all the employees based on the business entity key. And person detail, you will again see the person make the join to the person table. We can join both the tables based on business entity key. That single table will give you a combination of all the results from the employee table and the person detail table. So to do that, you can again go to home, and just above the append queries, you will have something called merge queries. That's what you do. Click on merge queries. Same thing will happen. The merge query, what will we do? It will merge the query in one of the tables that you put as first value. Now, don't confuse merge as something local to tab this Power BI thing or any particular tool. It's nothing but a fancy name for the joins that we do in SQL Server. I hope that's clear to you. We'll talk about joins a little later, more into detail, but it is something that we do joins on. And merge queries as new is something that will create again a new table joining the values instead of merging in an existing table. So let's go with merge as new to make things more simple for us. So let's take employee detail table as first table. So employee detail has also modified it as wrong. So let's fix it before going here because we want the right values. So now that we have fixed it, let's try to merge them. Pardon me, I directly clicked on merge, so it will add the values in first table. So we'll click on this drop down and merge queries as new. So now we have to merge these two tables. So on which key? Business entity key. Click on business entity key here. See, yeah, here it is writing select the same number of columns that both visible tables to continue. So I will select business entity. And it starts letting you know that the selection matches 290 of the 290 rows of first table. So this is the join point. If you see, is the left outer join. Let's make it an inner join for now. Again 290. So it is all the data in both the tables are matching right now, right? So that's why it is giving me that kind of thing. Let me expand it. So talking about joins, you can see these are the joins. So few of the joins will be more accordance to you would have heard of lately. Left join, right outer join, full outer join, inner join. But what is left anti and right anti join? As they say, left anti shows the rows only in first and right anti shows rows only in the second. Let's make it more clear with the help of Venn diagram. So I hope the Venn diagram is visible to all of you. I was searching for the right Venn diagram and I've found one on the Stack Overflow. So thanks to the person whoever posted it. I don't remember the name, but thanks to his courtesy. So yeah, as you can see in the Venn diagrams, this explains the joins that we will use. Make your concept very clear with the join. Don't go for the select statements that doesn't come in handy because Power BI does that thing for you. But do understand the logics what the joins mean. So the first one is the very first on the left, you will be a left join that will pull every data from the left table irrespective of the joining data exists or not, and all the data joining data from the right table. The second is the right outer join. It will do the opposite. Everything that you put on the second table will be pulled and they're joining values in first table. The third is obviously in the center, the most common join, inner join. It will only give you the similar to data between the both tables. This thing, which your A and B, which shows the whole of the data, is something what we call full outer join. And these are something that you use in general terms every day. But what this join signifies is a left anti-join, if I can say. What a left anti-join means is it will show all the data from A where a inner join data for a B doesn't exist. So the common intersection area data, it gets rid of that. So that's what a left anti-join is. And the right does the opposite. It shows the data from the right and removes the intersection data. So Power BI, pardon me, Power BI supports all the joins except for the very last one, that is the excluding the intersection data and showing A and B data. So that's the only value that Power BI doesn't do that, but all the other kind of joins, Power BI does support that. So I hope that explains to you all guys what the joins are and what Power BI supports in joins. Coming back to our dashboards. For our workbook and Power BI, we have chosen an inner join. Let's make things interesting and select full outer join. So there is a merge table. So we had put the first table as employee table, so its records are there. But then there is this thing. The person table details are still not showing, it is showing as table with this sign. What does this sign mean? Let's click on it. So it has all the rows of person table and it allows you to select which of the rows you want to keep in the output table and which of them you want to remove from their secondary table. So now like business entity key, that's already in my first table. That's the key on which I joined. So I will get rid of that. All the other things I will keep on except for the first team. There is something called aggregation. If we use that, instead of joining the values on row by row basis, it will on the business entity key, it will aggregate the value. So that is something that you use when you have a table with all the aggregated numerical values and one table with all the dimension values. In very near term, you will see one table is fact and another is dimension. So you will aggregate the values and pull it up. So that will help Power BI with lot of saving lot of space, which it will add while processing and that kind of stuff. But we are not doing that here. We will expand it and click on removing the business entity. And what is this? Use original column as name prefix. So what does this do is if I kept it as check, like it came from like person detail union. So for every column name, it will be person detail union dot person type, person detail union dot name style, and we don't want that. So I will click on remove it and click OK. And now you can see going further, all the tables records from second person table are also visible here, except for the last one that has a name change as modified date one, because there is already a column named modified date. So two tables can't have same name. So two columns with same name can't exist in a table. So we'll try to fix it. We'll simply right click on it. There's a rename option. and person modified date. And there we go. And there's another modified date. There we go. So these are employee modification dates. So I will rename it as so this makes us a table where we have everything. We have done a union and joined the table. That is in terms of Power BI, will say we have appended and merged the table and changed the data type to the right forms. But now we have to see that how much of if there is an error on our one of our rows, or if there is empty columns, we have to identify the number of empty rows, because if your half of your rows empty in your final output product, it don't gives a very meaningful output, right? So we'll go to view. I told you data profile, column quality, and data distribution play a very important role. Most people don't know it, but use it because it is very powerful tool. Click on column quality. Now you can see their error line is 0. So we have since correct data types everywhere. So there are no incorrect error data types. That is a row with invalid data. But we have a lot of empty data, as you can see, since we did a full outer join. So for all those datas for which there was no relevant data, an empty join was created. In table 2, that is employee table, there was way lot data than the person table, there was a way lot data than the employee table. So in second table, you can see everything is valid to 100%. But in table 1, there is a lot of empty table because there was no valid data against that. So how to fix it? Let's go back to this source. That's the beauty of Power BI. You can change anything at any step you want. So let's go to source and convert this full outer join to a inner only join. And when you click on that a particular step, the Power BI shows you your values at it was at that particular step. If I goes from source to expand, it will show me as expanded. And next to rename, it will show me as the renamed column. So now that I have turned the data from full outer join to an inner join, let's see the data profiling right now. So now everything is valid to 100% because it is taking everything from the both the common between the both tables. So let's do something different now. Let's take a left outer join, because in practical example, we always want to no employee detail to be missed. If a person detail is missed, it's okay with us. But an employee detail, that shouldn't be missed at any cost. So that's what we are doing. It's still good. So that makes everything right for us. Now there is something called remove duplicates. So if there were duplicate rows in your table, so you can remove them based on this particular key. Like business entity key is something that should be is the unique key, we would say, for your BI tool. When you come from warehouse, you have a business key that should always be unique. There shouldn't be two rows against a business unique key. If there is, we will treat that the data is incorrect. So to remove that, we will simply click on remove duplicates and it will remove that. Similarly, remove empty. If I click on that, it will remove any empty rows that there are. Since there are none here, as we can see in the our data quality, so it won't impact. And the third is remove errors. So it will remove all the rows that are incorrect and has the showing as errors. And last is replace value. If you want to replace any value with anything, you can do that. So let's select all the other data profiling stuff. Second is column distribution. The column distribution shows you how your data is distributed across. So if there is a distributed, like you can see how good your data is. Generally, your data should have an equidistribution or a similar distribution. If it hasn't, then there is something wrong with your data that you might have to check. Right? Like here, you can see a few departments have way lot data than other departments. So it still makes sense. It's a department-wise data, then it makes sense. But if it would have been something like marital state and something would have been 5% and other would have been 95%. And if your organizations implement gender equality, then you have to check with the data source that is something wrong with my data or something like that. That's what this particular column distribution does for you. And last one is the data profiling. In column distribution, you don't get exactly what is getting wrong. The data profiling thing actually shows you against which particular record how much of your data is profiled. Like here, if I select on, it shows me how much data is there against any particular column. So here, if I want to change or remove any values, I can simply click here. Click on replace value. Give me a second, pardon me. Yeah. Click on replace value. Are you sure you want to insert? Okay, it's at source step, so that's why it gave me a warning. Let's go to the rename step, and now I should do that because it would have otherwise done it before other steps. So let's go here and click on replace values. So like I want the word tool designer. If we add a null value, you can replace them to here. So like I have a word called tool designer. So my business has told me term it as a ETL designer. So I will term as that ETL designer and click on OK. And it will do all the changes. You can see it has been converted to ETL design. So such kind of value changes we can easily do in Power BI. So coming to more advanced of task of Power BI right now. After this, let's pull another data source. Before that, let's put all of these in a single folder. Move to group, new group. Let's give it merge and append. So now moving to our other data source, let's go to home. New data source. For this, we don't need to go back to Power BI. We can simply do it in mQuery itself, and we will import US Superstore. This data source will make us give us a good explanation what is data folding and native query and why it is important. So it's a pretty good data source, so you don't see any error or empty data sets kind of thing here. So we just have everything, just go and validate that everything is in right order. That is, the column names are correct. Well, they are. So now let's, since we have done the basic parts, let's move to something more. What are group by clause, what are pivot clause, and what are calculations? I told you that we can do calculations here, right? So what are the calculations that can be done inside M query that doesn't need DAX queries to went through? So for that, let's go to add column, and here there is something called custom column. Click on it. See, there's something called sales and profit. We'll add this to columns to get a revenue for your business. So I will click sales plus the auto suggest. See, there are products and queue functionalities. It will give that options too. But let's select the correct one. We'll name the column as revenue. And now you have a different column added, which generates the revenue. We can have done it easily in Dash 2, similar to this. But why are we doing it in mQuery? We'll learn that in a second. But before that, we get this. Another thing we can do is like break our values or a left or right text function kind of things. Let's go to this column. So I want the short name as first column. So I will right click on it. Split column by delimiter. And it has space as delimiter, as you can see. So leftmost delimiter split and okay. So we can give this a product short name. So such kind of basic things we can do in mQuery. These are very basic things that I'm telling you about. But let's move to something more powerful that mQuery does allow you to do. Let's move to date functions. So we have a sip date and order date here, right? So what we how to do a transformation? Obviously, you can go to custom query and write the date and function. But what if you don't know the calculations? That how the date function does? Simply go to this date column, this date icon, click on it, and you will get everything. Age. It will calculate the age from present day. Date only. It will, if it is a date time, it will only pull the date. Year. It will give you year date, the first day of year or end of the year. Same with months, weeks, and days. What it is not doing something fancy. What it's doing is instead of writing your queries of a day of the week or a day of the month, if you are thinking the calling of a logic, it is doing the thing of you through a UI. So let's go with a simple thing as year. Let's name as that order year. So this is giving you the order year. And if you see in the calculation, it is actually a mQuery, like a syntax. Insert year, name, and before that, if you rename, I move. Date.year order date. So it's a kind of a function it's mQuery writes, but it writes it for you instead of you learning by heart how to write that query. So that's the power of mQuery. You don't have to write things like as stuff, only date calculation kind of thing yourself. Now moving further, let's reduce our number of columns. So we can do something fancy here. I have selected all. I don't need to select all actually. What I need for my work is segment, revenue, and year. This will do. So I want to get rid of all the other columns than the one I selected. So I will right click on it and remove columns. If I click on remove columns, it will remove the selected columns. But when I want others columns to be removed, so I will click on remove other columns. Again, I was trying to do it before, so it is giving me error. That are you sure? So let's do it. It won't hurt me. So it has removed all the. Let's come to the last step. So it has removed all the other columns and left the three columns that we have selected with us. So now, what is a conditional formatting? We have seen custom, we have seen date time transaction, but then there is something called conditional formatting. What it does is click on this, and it does exactly what it says. That based on any condition, pardon me, let's bring it in the middle. Based on any conditions, you can create a row. Like, let's take order year. If our order year is 16, that is the very first year that we have. We have 16, 17, 18 in our data. So then it will be first year, and for all the rest columns, we'll use rest of the years. This such kind of things come very handy in YOY calculation, as we will see. So as you can see, using conditional column, instead of writing this whole each for each year a syntax, you did it using a UI platform. So that makes sense, I guess, for all of you. That being said, let's move to why we have narrowed down our column. Let's understand that. Let's get rid of. Okay, let it be. Let's not get rid of that. So I want the revenues not like for customer of 2018, there are multiple values. I want my values to be aggregated, because if the customer wants to see only three columns, that is his revenue against the order year for a segment. It doesn't make sense that I will bring value as this granularity. I should have more aggregated value to put less pressure on Power BI. So I'll take these three. Go to transformation. When I don't need to do that. From here, I will go to group by first before transformations. So yeah, now what are we grouping? Revenue we are not grouping on the basis of, we are grouping on the basis of segment, order year. Let's put it our custom column. The custom column won't, the custom column will make difference. So let's get rid of it. Let it be for now. We'll get rid of it later. So now on the basis of segment, orders and custom year that we have, it will aggregate the column that we give in the aggregation. So what we want is sum of revenue. So sum, column name revenue, and we will give the name as aggregated revenue. So see, what happened was that the same data that we were seeing, instead of seeing it row wise, it narrowed it down to aggregated values with the use of group by clause. And again, it's at the end of the day, it's a query that mQuery does for you instead of writing a great large number of syntax. So now we have our values ordered against the three segments, the 3 years, and obviously against them the custom column. The custom column doesn't make any difference because they are the same. For 2016, it's first year, and for the rest, it is rest of the year. So it is not impacting our data. So I'll let it be there. So now that being said, I want this particular revenue to be shown against a columns for each year, and for those columns I want this aggregated value to be shown. So can we do it? Let's try. So for that, let's go to data transformation where we have went before. There's something called pivot column. I will click on that. The pivot will do the same thing it generally does that it for you, that it will convert a row column into rows. So what value I need to pivot? Aggregated revenue against order year. So order year will make the column name and my revenue will be shown against it. So you can see for each year it is showing your revenue. Since this the first year only exists for 2016 and not for 2016, it will show you the revenue and null for others. So let's get rid of this column to make it more appealing. But that didn't help. We made a mistake. The mistake we made that we have to remove this column before aggregating because the value is already aggregated before removing this column. So let's move that remove column a step before. And let's move back. And now it's fixed. So everything, things which you needed to rewrite queries for, you can simply drag and drop in M query to aggregate and pivot your values. And so even if you have made a mistake, instead of rewriting and canceling everything. I hope that makes sense to you guys. So now we have for each segment revenues year wise. For unpivoting, we don't have to do anything if we ever need to unpivot. Simply click on the columns, select unpivot data, and it will bring back your data in the original form if you want to do. Obviously, you want to pivoting and unpivoting it in the same table. You will be doing either or other in practical examples, but I wanted to show you how both can be done. Now coming to why, I think the basics of how the M query does and how it functions, we have learned a lot about. This is the ETL part of Power BI. So we have learned a lot about that from what we have explored. I guess you would have also an understanding. But now the question arises, why do we use this an M query rather than DAX? I told you I'll explain that to you. That's caused something we call data folding. So what this data folding is and what this does, the question arises. There's something called view native query. This is important thing because this helps some value. People generally don't value this thing, and generally this helps you a lot with your practical dashboarding tool as well as how you approach in real life. Because until you know what a native query is and data folding is, you won't be able to create a good dashboard with a large data set in Power BI. So let's go here. You can see this view native query is disabled. If I go further, is it enabled? No, it is disabled everywhere here. So what is native query? Native query is something that only works with SQL server. So this is something that you won't be able to do alongside me, but bear me along. I will connect to a SQL server database at my end and show you what it does. So let's go to new data source, SQL server. I'll give it as localhost since it's installed in my machine. The same table that we have brought already, we are bringing it again. So it is named as order 2. I'll rename it as order SQL. And let's pair it. Let's do some of the transformations we did there here also. It will take hardly us 10 minutes, but that will understand what data folding is. Take sales plus profit. Put it as revenue. See here, we saw a problem here. When it was importing from Excel, it was treating date as data, but here it took as a date time. So let's fix it first. Instead of date time, let's take it as date. So same data set from two data source, it treats differently. So there is this problem that you need to always see if the correct data types are showing. So I will go to date and year function. Double click on it. The name is as order year. Get rid of other columns as we did before. So those of you who missed what I did, this is kind of revision. We can also drag and drop our columns if we want to restructure them. Like I wanted segment to be left, I just dragged and put it there. I'll click here and put group by. I want it to be grouped by these two instead of some sum of segments. No, please. Sum of revenue. Aggregated revenue. Now the last transformation which I did was pivoted. The basis of here, the values of aggregated revenue. Okay. So this is what we are getting. We don't rearrange it. We will rearrange it like 16, 17, 18, and 19. So this is the final table that we went and got in the last example. Let's move here and click on view native. It's not showing grayed out here also. Let's move a step previous step. Grayed out, group by. It's not grayed out now, as you can see. Let's right click on it. And that's what data folding means for you guys. What data folding does is that instead Power BI is smart enough to take as much of your calculations as possible And instead of doing it on the Power BI transformation, it rewrites a SQL query, say in Oracle, Power BI, in your SQL server or in a cloud, anywhere where SQL is supported. Okay. And it writes the query in such a way that instead of doing those calculations in the Power BI tool, the query will run on server end and do all the calculations and give you the output without the knowledge of you that these queries are running at the SQL server end or Oracle server end instead of the Power BI end. So that's the power of native query in the Power BI server. So that's why I wanted to explain to you why we prefer as much calculation in M query rather than DAX. Because once you do the calculation in DAX, it will do all of them in Power BI server end, and all the pressure and workload will be at server end of Power BI itself. But when you do it at the end of M query, if it's possible, the M query tab, Power BI is smart enough to do as much of that possible at your SQL server or Oracle that the data source end. So that's the what is native query is for. And that's what the term data folding means. Data folding means doing as much of your query at the data source end using M query rather than at the Power BI server end. So that explains data folding to you. I hope you guys are comfortable with that now. That being said, now this is our fine. But there are few things that the what we will say the Tableau, pardon me, the Power BI can't do at the data source end, like the pivot step. The pivot step it could not do at the data source end. It is something that the Power BI does at its own end. So for things like that, you simply can't do it at data source. So if you drag the pivot step at the very first or second step, what it will do it will distort everything. So that anything that comes after pivot step, even if it's a rename column or remove column kind of step, Power BI will have to do it at its end rather than data source end. So the concept of data folding is that do as much of queries that is possible at data source end in the even if you are doing it in Power Query before the running those kind of transformations, which can only be done at Power BI end. Otherwise, it will destroy all your data folding. So things like pivot or something in add column I haven't done. We have done custom column, conditional column, but not a index column. Index column is another thing that distorts your data folding. So with when you introduce a data index column, after that data folding simply isn't possible. Like let's insert an index column here. Let's move it to the last step. So the index column is here. Index column is nothing but adding a single index to your rows. So there are options. If you can start from 0, we can start from 1, or we can have a custom index that it's just like an index function we have in SQL Server or Oracle. We can start the starting value as like 5 and increment as 10. So it will be 5, 15, 25, such kind of things. But generally people starts with 0 and 1 because that's the most logical as it is used to identify the rows uniquely. So that's what the purpose of index column is. I hope you understand this. So now you can see up to group by the native query did exist. It wasn't grayed out. But what if I pick this indexed column and put it here? I have my outputs, so it can't find index column. Okay. Let's just get rid of index column because it won't be able to find it because we have removed it in earlier steps. So now we have the output column, but what impact bringing index column way above brought that did to us? Let's group to group by view native query is grayed out. Change data type, view native query is grayed out. Every calculation that you guys are now doing is getting done at Power BI end and using Power BI resources. Due to a mistake simple minor rookie mistake that what I did was that pulled the index column and put it at the very beginning. So everything like pivot, index, some things like that you should do at the very end. Unfortunately, there is no article or things like that where I could directly find that these are the steps that can be run at native query and which can't be. So it's like you have to check, but with experience, you will get familiarized with what can be done in the native query and which steps like index, column, or pivoting can be done, should be done at last. So let's that being done, I think we have done the basics of what a M query is and what's the ETL of Power Queries. We can move now to our BI end and learn what the after the ETL part of our Power BI is done, what the next steps are. So let's move, before do it, let's bring on another Excel file of orders. And one more thing before we leave this, there's something called Advanced Editor. If you ever click on this, you will see everything that you did using UI as a query here. This is the actual query that is running at the backend. So if you need to change anything, you can simply do it here instead of going at each step and changing that. For instance, I want to install what segment. If I wanted it to be order here, I can change it here. But what, if you are playing with this, be very careful that you are good at your M query end. Otherwise, you will make mistakes that can corrupt your whole of the transformations that you have done. Then you have to fix it, go back and fix it again. So be very careful. But for viewing what you have done in your whole transformation, you can see it here. So let's import the orders data source one more time without any transformation this time, and move to our so yeah, let's select it. One more thing that I almost forgot to tell you, very minor but very still important thing. When we import data from SQL Server, like we did last time, there is something called import and direct query. What import means that at the very instance when you import the data, your Power BI makes a duplicate of your data set, that is a copy of your data set from SQL Server into your Power BI server, and anything that you change at SQL Server after that doesn't reflect at Power BI end until you refresh your data set again, where it makes a new copy if you use the import mode. When you use a direct query, what it does is it doesn't make any copy of your data, and as long as every time you make a change at a SQL Server end, it will start reflecting at your Power BI end. It's similar to what extract and live connection does in Tableau. So every BI tool right now has something called an extract mode and a live connection setting. For Power BI, these are named as import and direct query. So many of you would ask why we won't use every time a direct query, because it gives you more live connection data rather than input. It's because of threshold. When you have GBs of data set, when your data set is like 2 GB, 3 GB, SQL Server's threshold doesn't support that much of data so quickly. And you don't want your client to, the business to wait at that, click a button on dashboard and wait for half an hour to see the graphs. So that's why if you don't have very high speed data source, you will use a import data rather than a direct query. So let's rename this. Since we have not touched anything, rename is orders unaltered. I'll close and finish this. And you can see it is import now doing all the importing the data and everything for my Power BI. That is the ETL part, the M query has been done and it is importing the data to be used at my front end. So that makes it right. Now we are back to our Power BI window. Here we can see all the tables that we have imported are showing us here. If I go to table view, as I told you, we'll be able to see every table as a value, tabular value here. And the last is relationship. We'll learn a little more about it later. But for now, what you can see here is, let me reduce it. Our BI is way smart to find the column fields and create a relationship between them. Like between person detail, if you click on this particular firm, based on business entity, it has created. So it's not a right relationship because we have merged everything already. So that doesn't make sense right now because the merge one has all the details that we needed. But in general, if you have tables distributed and have common keys, understand that Power BI relationship model is smart enough to identify those columns and join it for you. So if you click on anything, any of the column, it shows you how the relationship it's made on business key, have a cardinality and cross filtration, which we'll talk about more in later chapters. But then the bottom line here is that the Power BI does things like that for you. Instead of if it's a simple relationship, Power BI will do that, create those relationship for you without you even using a single query. So that being said, let's move to and create some simple visualization. We won't go deep into, but we'll see what we are trying to do. So this order table is the one table where we aggregated all the values, right? Let's select a stacked column chart. Since we have single value, it won't work as stacked. It will work as column chart rather than stacked, but let's do it. In the values, we'll put the values and segment as axis. And attribute as my legends. So now, according to each year, it is showing me how much of the profit it is kind of entertaining, as you can see. Sorry, I used the wrong word, profit. It should be revenue. It is entertaining. So this is what, if we have to see simple this value without showing the user the granularity of data, that which business is making such kind of value. So these three columns would have been enough for me to get my data aggregated and show as the output. It will make a very less data set for my Power BI tool and will make it the refresh and data source accessibility very fast. But then why in more practical ways we generally use such kind of data sources, as I'm saying, unaltered rather than this kind. I will explain to you too. Let's again come here, put another chart. Let's put it here. We'll again take those three columns. One was revenue. So we don't have a revenue here. So let's create one, profit plus sales, right? So I'll right click here, new column. I'll rename as revenue. Now, and the revenue column that I'm creating right now is in DAX. That is in the Power BI, the language we use is DAX. It's not the same M query that we used in the Power Editor window. That was a different language itself altogether. But the benefit there was that you could have used a data folding there. But here, you simply can't do that. It's all working here. Let's search for profit. I think sales, it took some from somewhere else. So I will, yeah, take sales from here. So it is here you can see it is showing as the table name dot column name as, because if you have a relationship, you can add columns belonging to two different tables also. So that's why it is showing the name as a fully qualified, that the table name dot column name. So that makes my revenue. I'll take revenue and put it into, pardon me, value section. I'll search from segment. And now the third was year. But we don't have year here again. So what we'll do is right click on order date. New column. Mind you, these all are calculations that we are doing in DAX, not an M query. Keep that in mind. So data folding can't work here. So if you have a, as we told, as much of that it is possible in a practical project, we'll try to do it in M query rather than in DAX. So I'll put it here. And you can see the both charts are giving you the same values, right? Because in one, what we have done is we aggregated the value and did pull it everything at the data source itself. That is the ETL part of Power BI. We can say that M query section and in Power Query. And instead here we are doing everything in the Power BI interface using DAX. So if you have to show only single chart or 5 or 4 charts with no granularity, then this is way better because this will be more effective. Such kind of things have become more effective when you have to show granular data and show relation between this. Let me show you like, oh, pardon me. Now I have brought a table function here. I'll put values like for every category, there will be some subcategory. And for subcategory, we'll have revenue. And let's take order year too. Right? So it's a simple chart. So before we move further, let's break the relationship because I don't want a wrong relationship altering other things. So let's delete this relationship. That being done, now this is what I was telling about the difference that comes. What happened was that when I clicked on furniture, it is showing me for furniture segment, what is the value that is being highlighted. You can go to view. Sorry, form edit interaction, and I can change it to, let's change it to highlight to filter. We'll read it in way much detail further. but I just wanted you to understand why we use things like more data set, more columns than in a single graph. Why not pull aggregated data itself altogether? So things as such, when we click on office supplies, it will filter my data for office supplies for every year. When I click on paper, it will filter my data set for papers of office supplies divided by year wise and segment. Things as such wouldn't be possible if you already aggregate your data too much and split it across two data sources. So that's why you need to aggregate your data, keeping in mind how much granularity the user wants to see. Somebody asked that both of them charts looked exactly the same. Look at the revenue scale. One is up to million of data, other is up to 60K. So that's where difference is coming on. That will make it quite evident to you. Let's enable data labels on both the charts. And I skip everything. So now the both charts are matching, right? Exactly, we can say. I am not like they are matching close or anything like they are exactly matching. We can see since the value labels are showing them as matched. But what happens when I click on office furniture? My this particular chart of the right gets filtered out based on the office supplies and application. So for the subcategory as application and office supplies, it is distributing my values across the years and segment. Whereas the first chart where there is no relationship between office supplies and segment, it simply is not filtering your data based on your selection. Similarly, for all the technologies, it will work. So that's what I was trying to tell you. Do aggregate your data. Obviously, it's a good thing. But before you aggregate, confirm with business which are the columns that they would need in your final reports and what's the granularity. If there is a column like customer ID, I don't think anybody will need that. If I'm sure about that, then I can remove that customer ID column and aggregate the measures against all the dimension values that there exist. Now you will be, I would make a more genuine, what will we say, simple definition of what measure or dimension is since we are talking about it here. So in those terms, a measure is something that can be aggregated. So any numeric value like sales, uh, profit, revenue, discount, these will be called measures. Whereas anything that is used as a field against which these aggregated values works are called as dimensions, such as like what we can say here, the segment, the category, the subcategory kind of thing. So they will be called as dimensions. Numbers are always measures and text are always dimension, which is a very wrong assumption because let's assume there is something called business ID, business entity ID. So that will give you an entity ID of business that shouldn't be used as a measure. That will be always treated as a dimension. So it's your understanding how to which values should be as measure and which value should be a dimension. But generally, in terms of Power BI, Tableau, ClickView, any BI tool, we use these two terms. So anything on the basis of which we aggregate our value is a dimension, and the values that are being aggregated are called measures. I hope that makes sense to you. So we will have used two simple charts and we have a bit time left. So we will use something called slicer to make everything look more evident. Let's take subcategory and put in the value of slicer. And convert my slicer It's a select all option. So there is a select all option here. So what this does is, what slices are actually, let me tell you that. Slices are nothing but they are like a what we'll say filters kind of thing which is visible to users. So user can use slices to filter data based on whatever requirements you want. Like if anybody wants to see the data of art and binders, so I have not so for that it's a control for multiple selection, right? So if I simply select, it will show me single values. So art, binder, bookmarks, and chairs. Pardon me, I think yeah, pardon. So I have multiple selections. So you can see these three binders, chairs, and bookmarks, and their respective revenues are being selected across the two graphs where the slicer is working on. Here, obviously, there is no relation between the category table and the segment table. So that's why this slicer ain't working. So if you use something like segment, because segment is something that's in both the tables. So I guess that should work, right? Let's put segment here. Sorry. So what has happened is, okay, here is segment. So now we have a segment table. So if I select corporate, but it didn't work. There is a corporate filtered here. There is a corporate filtered here. If I, let me show you. Wait, let's take segment and put it in this table. So it will be more evident to you. So you can see it's showing only corporate details, right? But this is not. So why it is not and how to fix it? The problem lies with the relationship. The tables that we are using, let's go back and see which tables we are using. Orders unaltered, and for this, what are the tables we are using? The orders table. Let's get rid of this relationship. So these two tables doesn't have any relationship right now. So what we'll go is right here, manage relationship, new relationship, orders, and orders unallocated. On which row? Segment. So just the way we select the column name there in our M query, here also we'll select the column names. So it is telling it has a cardinality of to many. So be careful with that. We generally should avoid cardinality of many to many. But since we are just doing it for namesake here, so we will go with it. Cross filtering can be one directional or two directional. So if I do a single directional from unaltered orders, so what will it do? For every filter that I do in unaltered table, it will filter the data in orders table, but not the opposite way around. For our convenience, I am putting it as both here. Maybe in future we will simplify it. So you can see there is a relationship. Now on the segment columns, let's move back. And now you are seeing that it is filtering corporate at both the ends. The table that was not getting filtered is now getting filtered. So that's pretty much what we can say a relationship does for you. These two tables are not practically joined, right? There is no common table which has holding the data from both the tables, since they are very different granularity. But based on the relationship that we created, it is filtering data between the two tables. Similar to do, we can do calculation, taking columns for two different tables and creating a third column on that. Such kind of things is possible in Power BI. So that's the brief of introduction of what a relationship was and how graphs can be plotted against it. If I select a home here, it will filter that everything. If I use control and customers and home here, it will filter all my charts accordingly. So such is the power of Power BI. With the help of relationship and graphs, you can create such kind of things. But the very beginning step, people undermine it, but use mQuery as much as possible to do as many calculations at the very beginning end, so that you don't put the pressure at Power BI server end and instead put the workload on data source ends, because they are more efficient for doing such kind of things. So I hope you would be been able to understand what I was trying to teach. If in doubt, you can always reach out to me via Broad Infinity, and we can solve your doubts and problem. So I think that makes enough for today. We can call it a day. If anybody has any doubt, I'm available for next 5 minutes. You can ping your queries and I will answer them.
Dear students, if you have any questions, you can put in the chat window, and coach will be answering those questions. And the students who are joined on the YouTube, they can directly ask the questions on the YouTube, and I'll be forwarding to the coach. And yes. If you don't have any questions in the meanwhile, I have shared the two links with you. One is for the certificate, second is for the feedback. So make sure before leaving the session, you have given your feedback in the feedback link. Okay.
So I guess people don't really have doubt right now. If you have ladder, always reach out to Bird Infinity and they will reach out to me. We will be more than happy to help. But for now, I think we can call this the end of the day.
So thank you so much, sir, for the informative sessions. And I'm assuming that now students have the better understanding of the Power BI tool. And it was really a great session. Looking forward for the further session as well. And thank you so much, audience, for the so much of interactive, and you were asking so much of questions to the coaches. And we are hoping that this session made you more informative in terms of the knowledge and understanding. So thank you so much, everyone.